margin of error, m is equal to c star sigma over square root of n, is going to give you the formula for the sample size, which is c star sigma over
Chapter 15.
margin of error. M is the mo or the margin of error. This m is your margin of error. And what are the keywords for margin of error? So the keywords for margin of error is plus or minus, keywords for mo. It is plus or minus, or it will have within, or it will have with. What is the with? With is going to be the twice the margin of error. With is going to be twice the margin of error. Or you can say the difference between the upper limit minus the lower limit. Upper limit minus the lower limit. Or the difference between the bottom or the lower limit or the lower boundary and the upper boundary. All right. So these are all the keywords that you will be seeing in your problem. All right. Again, formula based. Check, check, check. Plug it in. You will be good. All right. All right, so this is the formula that's going to be used for finding the sample size. So pretty much you are going to be using the C star value, the sigma value, and then the mo, right? And then use the numerator number, the denominator number in your formula, and then do not forget to square it. Only if you square it, you get the value of n, otherwise you are solving for square root of n. We do not want the value for square root of n. We want the value for n, which is the sample size. The distribution of total body protein in adult men with liver cirrhosis is approximately normal with the standard deviation. So you are talking about all adult men, and you are talking about the total body protein. So you are given the quantitative data, and this is going to have the standard deviation, which is 0.1 kg. The number coming from the population of all adult men is going to be the population. So the population is going to give you the number, standard deviation, and that number is 0.01. All right. So now how big the sample should be if the margin of error is going to be. So the margin of error, the mo is going to be, I told you that it's going to be plus or minus 1. So the margin of error is just about 0.01 kg, not more than that. Okay. And what is the sea level? The sea level is your 95 percentage. So the sea level is 95 percentage. That's right. Now you are going to find how big the sample should be. So what is the sample size? So this is your question, how big the sample should be. So in order to get the sample size, write the formula, okay? So it is going to be Z star times sigma over MOE square it. Check, 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 plug it in. That's it. Because your Z star is going to be plus or minus 1.96, and the margin of error is also going to have the plus or minus 1.6. But you don't have to write the plus or minus sign because it goes away though. If you want, I can write it. So it's going to be plus or minus 1.96, and then your sigma value is 0.1 over the margin of error is 0.01, and then it's going to have the plus or minus sign too, because the margin of error is going to be on either side from the center. So now what I'm going to say is, obviously you can cut the plus or minus sign uh, both in the numerator and the denominator, and then do not forget to square it. I keep telling, because this is the common mistake the students make, they forget to square that. Okay, so this is going to be equal to 1.96. I'm just using my calculator. 1.96, open parenthesis, 0.1, which is the standard deviation value. And I am going to divide this number by 0.01 equals, and then square it. So the number is 384.16. Because n is the sample size, I'm going to approximately write it as 385, because round it up. the part of it, you make it as a whole, one full sample, and round it up to 85 samples. So what is the sample size? In order to have a small margin of error, which is 0.01, you need to increase the sample size. So the margin of error is a smaller number, which is 0.01 kg on either side from the center. For having that kind of small margin of error, you should have a huge sample size, which is 355 samples.
So you always round it up no matter what the number
That
is on
is
the other side?
correct. That is correct. The part of it is treated as a whole number. The part after the decimal, whatever is the tiny part that you have, treat it as a whole number and then always round it up and make it as a whole number. Do not leave it in decimal value. Round it up. Do not leave it in decimal value because it's your sample size. Okay, so another problem I guess you can do, but here the margin of error is a point. So this is your margin of error, the plus or minus n. So the MOE is going to be equal to plus or minus 0.02, and your standard deviation is still the same. So now you are increasing the margin of error to 0.02. So let's see what is the sample size. So with the C level is equal to 90 percentage, your Z star is going to be plugged in, which is plus or minus 1.645. So that is going to be the critical value. So your formula is going to be Z star sigma over the margin of error, the whole square. Remember the formula, or you can also make your formula card. So this is 1.645, and then your sigma is still 0.1, but you're just increasing your margin of error to 0.01. So that way the denominator is going to be 0.02. Do not forget to square. That's very important. So that's going to be equal to, now I'm going to use my TI. So move the cursor, 1.645 times 1.645. You already got the number? No? Okay. I thought
68.
The number. Okay. Divided by 0.02. Square it. It is 68. Good job. Thank you. So just see the difference. Just about 0.1 margin of error I'm increasing. So that's the fixed number. That's a fixed number that I have. And then the sample size is going to be almost like 1/4. Is that right? Or 1/5, I would say 1/5. It reduced to 1/5. So this is going to be 67.65, approximately 68 samples. So what you see, just about 0.01 increase in the margin of error, you are seeing the drastic lower number in your sample size, or your sample size goes down drastically to 1/5, which is around 68 samples. Now, the next problem is going to be having a very, 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 very tiny margin of error. So the tiny margin of error on either side is going to be just about 0.0001. Look at the accuracy of your margin of error. And look at the accuracy of your margin of error, which is negative 0.0001. So you are seeing the variations in the margin of error, and you are also going to see the changes in your sample size. So with your C level, which is going to be 95 percentage, you are going to see how big the sample should be. So your C level is a 95 percentage, and your Z star value is going to be plus or minus 1.96. So n is equal to, your formula is Z star times sigma over MOE the whole square. So the C star value is 1.96. Check, plug it in. That's it. Okay. And what is your standard deviation? The standard deviation is again a tiny number, which is 0.01. And margin of error is a very, very tiny number. You don't have to put the plus or minus sign, but that plus or minus sign cancels with the numerator plus or minus sign and the denominator plus or minus sign. You don't have to write that. Okay. So I'm going to plug it in, and the sample size is going to be huge because the tiny margin of error, there you go, that is correct. I'm going to copy down the number my friend gave me, which is going to be 38,416 samples. That's right. Tiny margin of error, very, very little margin of error you need to go. So that margin of error is a number that you are fixing. For that fixed number of margin of error, you end up getting a bigger sample size. All right, so now you are going to be finding, so this is another example where you are going to plug in the data, okay? So now this time I'm going to use my data, and it's going to be in, I don't know where I'm going to look for the place for plugging in the data. So I have the sample of n is equal to 4 observations. So this is chapter 14 because you're going to be finding the confidence limits as well the sample size. So what is the 99% confidence limits? So I am going to see where my which column is available. Yeah, L5 is available. Okay, let me plug it in L5. So I have L5 available. So I'm going to plug in the data into L5. So the observations are 63, 69, 62, and then 66. I have a tiny data with the 4 observation. And for this one, I showed you how to use the TI, right? When the data is given. So now I'm going to have the input screen. But before that, let me make sure to plug in the data, which is 63, and then hit enter, and then 69, hit enter, and then 62, hit enter, 66. I guess you are also working with me simultaneously with your calculator. Okay, so have the practice of using the calculator. Okay, so start and then move on to test, and then select option number 7, which is the Z interval for you. Okay, so the input screen is going to be now input screen. So this time I'm going to be selecting the data and the stats ruled out. So stats is ruled out. I'm going to be selecting the data. All right, so now my sigma value is going to be sigma is equal to 0. What is the sigma? 2.4. Oh, you already got the number. Super good. All right, but I will just write it because now my eyes are in my TI. So 2.4, and then my data is in L5. I don't know where you stored it. Second L5, just I have it in L5, and then the frequency is 1, which is the default. And then I'm going to move the cursor down to 99. So the C level is in 99. And then hit calculate. And then we'll be getting the output screen. Let's do that. So 0.99 and then hit calculate. So the lower boundary is a 64.99 and then the upper boundary is a 65.0. And then my X bar value is 65, which is a sample mean, and then the sample standard deviation is 3.162277. I'm just writing all the gradient digits, and then my N is going to be 4. Are you all getting the input screen and the output screen like this? Are you working with me?
I didn't get that. I'm not sure. I plugged in all the same values. I'm also have a question about how do you know what numerical value to put for frequency?
It's default 1. You don't have to worry about it.
It's always 1.
That's correct.
Okay.
Because every single frequency, we are assuming it is occurring only one time.
Okay. So I did all these things.
Mhm.
My calculator looks the same, and then when I calculate, I've got for the z interval 317.9, comma 320.6.
Can you please check the numbers that I entered versus your numbers?
So I'm in stat test
Mhm.
7 for z interval. I'm on data screen so that I can put in the list.
Mhm.
Sigma is 2.4. The
Correct.
list is L5, and I did do the same list. Let me check that and make sure.
C interval, did you put 0.99?
Mm-hmm. So I wonder. I messed up my list. I thought it said L5. It didn't. Okay, sorry. Never mind.
Good job. All right, so that's it. So you are answering the first question. So probability that your mu is expected to fall between these two numbers. How confident you are? You are about 99% confident that it's going to be between the two numbers, 65 to 60, or exactly, I'm going to put the numbers, which is going to be 64.992. Just the margin of error is very low, less than mu, less than 65. That's right. The margin of error is very low number. Okay. All right. So now, what would be, so with the same problem, you are going to find how big the sample should be if you want to keep the margin of error as 1 inch. So if the margin of error is going to be 1 inch, how big the sample should be, the confidence level is given. So check, plug it into your formula. That's it. Your number for 99 percentage is 2.56, and then you are going to have the sigma, which is 2.4, and then 1 inch. So it's going to be the whole square. Margin of error is 1 inch. So your with the 1 inch, you are going to have the problem with the 2.576 multiplied by 2.4, and then you square it, which is about 38.222246976. It's approximately 39 samples. So always make sure to round it up. So with your margin of error as 1 inch, you need to pick about 939 samples. All right. So,
Mr. Bala, can I ask a quick question? Can you? Do you mind just going over the question based on these data? 99% confidence interval for mu in days is P6499. Where those numbers came from? Do you see what I'm talking about?
from the confidence level. The confidence level. Based on this data, you are finding the 99% confidence limits for mu. That number is given by my TI though.
Right. So my TI. Sorry, could you scroll the screen to the right to so I can just check my inputs?
It's coming. It's coming. Yeah.
I'm still not. I still got different numbers on the top. I don't know what.
Yeah, me too.
I got 61.9.
Oh, really? Oh, maybe, okay. Maybe. I will double check on the numbers that I entered because I'm not good in. I kept the same sigma. I'm sorry. I kept the same sigma that I got from the previous problem. I did not change it. It should be 2.4, right? I'm sorry. I should have changed it to 2.4. I kept the same number, which is 0.0068. Okay, now I'm changing it. So L5 frequency 1, hit calculate. Okay, thank you. That is correct. That is correct. All right. So now 61.909. Is it correct?
Yes, that's what I got. Thank you.
That's right. Because I did not change my sigma value to, because I was writing here as 2.4, but I forgot to change it in my calculator. I should have done that. Okay, that's right. 68.491. All right. So now the numbers, yeah, so everything is good now. So now my lower boundary and the upper boundary. So what is the lower boundary? Oh, come on. I know. I have to be very, very gentle. Hang in there, okay? I'm just moving very slowly. Here we are. Okay, so now I need to fix that here. That's what I was wondering. Very close. The numbers were kind of 65, 65. While writing, I realized. Thank you, Annie. Thank you for bringing it up.
Yeah, no problem. And while we're just waiting,
thank you.
Someone asked the other day which chapters. We have the test on Monday, correct? I know you've said it multiple times. Which chapters is that?
Everything except the test. I'll show it to you. I put a note in my OneNote. I'll show it to you. 68.091. That's right. So how confident I am? This is the. Let me finish and then I'll show it to you. Okay, we still have 10 minutes time. So this is the diagram, and then this diagram is giving me the mean value. So the mean value for my data is 65. So with the 65, yes, 65. And what is the bottom number? The bottom number is 61.1. And then 61.9. And then the top number is 68.1. All right. So how confident I am? I am about C is equal to 99%. And what is the margin of error? The margin of error is going to be the difference between these two numbers, which is going to be 3.1 inches. And what is the difference between these two numbers? It is again negative 3.1 inches. Negative 3.1 inches. Is that correct? Do you see my diagram, the normal curve? Do you see my normal curve?
Yeah, we see.
Yes. So with the 99% confidence interval, this is my diagram. This is my diagram for, just give me some time because my tablet is very hard. It's struggling. All right. Now it's all good. Do you see the screen?
Yeah, we see the screen.
All right, good. No, it's taking some time to bring it up. That's why I was wondering. Okay, so now this is what I'm going to be telling you. The center is 65, which is the X bar value. The X bar value is 65, and on either side with the 3.1 inches margin of error, I get the 99% confidence limits. Now, the next question is, you don't want 3.1 inches margin of error. Suppose you want to have only 1 inch margin of error, how big the sample should be. So with the 1 inch margin of error, the 4 samples is not good enough. You need to have about 39 samples. So now the another diagram that I'm going to be drawing here is going to be, so with 1%, with the 1%, the 1 inch. So the 1 inch margin of error, so the margin of error is going to be 1 inch. If you are fixing this number, then your sample should be close to 40. Margin of error is going to be 1 inch, which is going to be the negative 1 inch. With the negative 1 inch, how big the sample should be? The sample should be about 39, which is nearly about 10 times. The first one, you had about 4 samples, and for 1 inch margin of error, it should be 10 times bigger than the original sample. So this one, you are saying your n should be equal to 5. Now do you understand how the margin of error and then the sample size, and then your sea level playing here. Anybody has any question? No question? I don't know. You have.
I'm wondering where the inch comes into play. Maybe I missed it because I had to step away from my computer for a second. But where's the 1 inch?
Margin of error.
I know, but okay. So where's the unit inches in the previous portion?
Because you're talking about the tomato plant height, or how long it's going to grow, not the height, the size of the tomato plant, if it is going to be 1 inch bigger in size.
I thought those numbers were days.
Yeah, the days versus the margin of error is going to be, if it is going to be 1 inch bigger in size.
Okay, so 63 is the
days.
The days.
Mm-hmm. So if it is going to be 1 inch bigger, how long it's going to take? How many days? So there is a correlation between the number of days is going to be there and then the size.
Okay.
Mm-hmm. So if it is going to be, if you wanted to have the margin of error, which is the 99% confidence interval, if it is going to be maybe 1 inch or 1 day, why 1 inch? Now I'm just thinking about the typo error I made. Maybe this could be day. This could be the day. That's right. That could be the day. That's right. Because everything is in days though. Yeah. Maybe that's my typo. Maybe I can just change.
Okay, that makes more sense than.
Yeah. Now I'm just seeing the typo. I made it. All right. So that's not the inch. That's the day. 1 day, not 1 inch. 1 day. Now makes sense?
Yes.
Mm-hmm. That's right. All right, so now if it is going to be 1 day more, because you are going to be taking the days on your horizontal axis, so that's going to be taken on the horizontal axis with the margin of error of 3 days. You're getting the lower boundary and the upper boundary with the confidence level, and with 1 day, you need to have a sample of 39 plants, 39 tomato plants. So with the same confidence level, but margin of error, you're restricting it to 1 day on either side. So the same concept, and you can try all these problems. So the answer is there. So now regarding the exam. So the other class, they were asking me the question about the exam. I put under chapter 14, but I will be sending you both my review questions. Okay. Yeah, this is the untitled page. So this is the information regarding your exam. All right. So this is the exam 2 info. So the exam 2 is going to include chapter 9, the discrete probability model, and then the uniform distribution, otherwise known as the rectangular distribution. So you took the sampling learning homework. You also took the Canvas quiz on chapter 9 and 10. So you should know what I'm talking about. And then chapter 10, we talked about the 2B table, the conditional probability, the multiplication rule. Okay. So that is going to be there. And then the chapter 11 is the normal distribution using 68, 95, 99.7 rule, and then the Z table, and using the Z score or the TI 8384. TI 8384 using the Z-score, okay? So software as well the Z table. And then the 13, which is the sampling distribution of X bar, and then the sample proportion, which is the P hat. You know the central limit theorem. So the central limit theorem for the quantitative variable and the qualitative variable, and the confidence limits for mu. No testing of hypothesis. I'm not including the testing of hypothesis. So that I'm going to start tomorrow. Okay, and then Friday I will do a tiny review on that because we don't have time. We still have one more chapter to cover. So 14, the confidence interval part is there, and then chapter 15, finding the sample size is there. Okay, so now you can complete the homework on chapter 15, and I have given you the extension on chapter 14. So the chapter 14 SL due on June 10th, if I'm correct. I'm sure I should be able to complete it before June 10th. Chapter 15, which is finding N, and that's due on June 8th. June 8th. And then exam 2 is going to be available on June 7th, which is Sunday, and June 8th, which is Monday. So it's going to be available for 48 hours. Available for 48 hours.
So the chapter 14 homework is due after the exam, but that content will still
Only the testing of hypothesis. You can try the confidence interval part. You can try and see how the confidence interval is going to be done. Only the testing of hypothesis, I'm just extending it. You understand that?
I'm not sure.
So this will have two components. I'm sorry, not this one. The chapter 14 will have two components. One is the confidence interval. So wherever you see the confidence interval, you just get the feel of getting the lower boundary and the upper boundary for me. Okay? This can be done because we already finished it. The second one, some questions will have the testing of hypothesis because it's going to be jumbled up. So the testing of hypothesis, you are going to have the keyword of claim. It's not going to be like your confidence interval. The confidence interval, you will be getting the 90%, 95%, 99%. So these numbers are going to be given in your confidence interval problem because we did a lot of problems with the worksheet and everything, right? So in every single problem related to the confidence interval, you will be given the C level. So if you are given the C level, the problem can be done. You are going to use the X bar plus or minus the margin of error formula to get the lower boundary and the upper boundary. So that problem can be done if you are going to have a good practice on that. But only part of it, you may not be able to do that. So that is the testing of hypothesis. The testing of hypothesis problem will be totally looking different. So if the problem is not talking about the confidence interval, yes, that is related to the testing of hypothesis. You don't have to do that. So that's why I have extended the due date to June 10th. But right now, today, you can complete the chapter 15 problem because it's based on the sample size formula. It is Z star sigma over mu the whole square. So it is going to be just based on only this formula. So that is due today, due on 18th, and the same day you are going to have your exam. But anyway, you can also do it on the same day or day before your exam too, to get the feel of how the chapter 5 questions are looking like. Okay? So the part of your chapter 14, as long as the question is talking about the confidence interval, you should be able to do that. Make sense?
Thank you.
Mm-hmm. All right, it's 12:23, so we'll see you tomorrow, okay?
Bye.
Bye. Bye.